Okay, this is number 11 from the Arcs and Chords Kuta software worksheet. I'll place a link to the worksheet below. I definitely recommend doing it. It's great practice and it includes solutions. Okay, so this is a tough one. Sometimes it's hard to know how to start these, but just be persistent. Keep thinking of what you know. One thing I see right away, I see two radii on here. Here's one radius, and here's another one. So one thing I know that this whole length here is 16.7. That doesn't solve our problem right away or anything, but it's worth noting. What else do we know? Okay, well, we know from our perpendicular bisector theorem, which says that if I have a chord like this, and I have a radius that intersects our chord at a right angle, just like this radius does, then I know that these two segments of that chord are equal. So what that means for us is that this side must also be 15. So if that's 15, this is 15 because of our perpendicular bisector theorem for circles. Okay, so we're making progress. I think now we're going to have to get a little bit sneaky, and there's probably more than one way to solve this problem, and that's fine. You may think of another way. If you do, fantastic. Here's my way that I'm thinking about. I'm going to take this radius, and I'm just going to draw, well, I guess I'll just draw another radius, basically, right here. My circle isn't drawn that well, and that's okay. So here is another radius, and its length is 16.7, just like this radius. We know that all radii have the same length. But what I've done here on purpose is I've made us a little right triangle. And I know that this is a right angle as well, because angles that are on a line like this must add up to 180. So if this is 90, the leftover must be 90. All right. Now I think we can actually start doing a little bit of work here. So if we know it's a right triangle, I'm gonna take this triangle actually and draw it over here real quick. I'm gonna kind of flip it around too. So I'm gonna call this side maybe y, right? And this is my hypotenuse, because notice that it's across from or opposite the right angle. So I need to put it on the long side, the hypotenuse side. And then these sides don't matter, so that you can switch them and there won't be a problem. So there we go. Now we can use our Pythagorean theorem. So we can say a squared plus b squared equals c squared. All right. A in this case we'll say is 15 squared plus y squared equals 16.7 squared. And now it's calculator time. 16.7 squared is 287.89. I'm going to go ahead and subtract 15 squared, which I believe is 225, and we get y squared equals 53.89. Take the square root of both sides, and we'll get 7.34 is y. Okay, so we have y, and now our job shouldn't be too hard, because we know that the entire length of this piece is 16.7, and we know that this section of it is 7.3. So we have the whole thing, and we have the piece, so x should just be the leftover. So we should be able to say that x is equal to the length of our whole radius, which is 16.7, minus y, which is 7.34, and we'll get, let's see here, 16.7, and I'm going to subtract answer, that's just the last thing I had in my calculator, equals 9.36. Okay, so there we go, x equals 9.36. Let's check our solution. They're saying 9.4, so they rounded it a little differently, but no problem. So they ran it to the nearest tenth. Either answer should be okay unless your teacher specifically says that they want a certain level of rounding. Okay, great. If you have any more questions on this problem or other problems on the worksheet or other worksheets, feel free to add a comment below or send me an email.